This conference will now be recorded.
In last session, we were discussing about what is Terraform, right? What are the advantages with the Terraform and the Terraform architecture, the advantages of Terraform and the Terraform architecture. So let me quickly recap whatever has been discussed here. So last class we discussed till here, right? The Terraform architecture. Let me quickly recap what is Terraform. So Terraform is a free and open source infrastructure as a code tool from HashiCorp. Terraform will allow us to define resources. Terraform will allow us to define resources and an infrastructure in a human readable, declarative configuration files. And Terraform manages your infrastructure life cycle. Terraform is a provisioning software. Terraform is an open source provisioning software. You can provision the resources like compute instances, storage, networks, managed databases, managed Kubernetes clusters, or any resources. You can provision and manage the infrastructure and other resources using Terraform. So Terraform is open source and declarative. It's an open source and declarative model. In last class we have discussed what is declarative, what is imperative. Declarative means you define what you need, what resources you need. You define the end state, you define the desired or end state rather than describing exactly each step how to do it. You no need to define how to achieve the desired state. You no need to write a code, step by step code in a procedural format. So instead, you just define what you need. You just define your desired state, end state. Terraform knows how to do it. Terraform knows how to do it, how to achieve the desired state. So Terraform enables management of any infrastructure such as public clouds like AWS, Azure, GCP, and private clouds like VMware or OpenStack, or any SaaS services, or any other platforms which supports providers, right? So Terraform is a stateful application. Terraform is a stateful application. What do you mean by stateful application? Terraform is going to maintain the state of each and every resource it is managing. Terraform is a stateful application. What that means, it is going to keep a track of everything. It is going to keep a track of everything it is building in your environments, in your cloud environments, so that if you need to change something or deleting something later, Terraform will know what it is built and it can go back and make the changes for you. Terraform is going to maintain the state. It's a stateful application. So what is advantages with the Terraform? Terraform can manage Terraform can manage infrastructure on multiple cloud platforms. Using Terraform, you can manage your infrastructure resources on any cloud provider, such as AWS or Azure or GCP or DigitalOcean or any cloud platform. We can create and manage the infrastructure. Terraform is a human readable configuration language. The human readable configuration language allow you to write infrastructure code quickly. As I already told, Terraform state allow you to track resource changes throughout your deployments. Whatever resources you are deploying using Terraform, Terraform will maintain the state of your resources, and you can maintain your Terraform configurations, your Terraform scripts into a version control system, so that multiple team members can collaborate and work on the infrastructure as a code. So the features of Terraform basically orchestration. Terraform is going to orchestrate your infrastructure resources. Terraform is going to orchestrate your infrastructure resources. Terraform act as a orchestration process. Terraform will act as the core of orchestration process when it comes to creating, updating, deleting low level resources like a virtual machines, storage and network resources, load balancers, or high level components like DNS records and Kubernetes clusters, databases, etc. Terraform is going to act as an orchestration or provisioning and orchestrating software when it comes to resources. Provisioning, orchestration and provisioning when it comes to infrastructure resources. And Terraform manages any infrastructure. As I already told, Terraform manages any infrastructure. Terraform, there is something called providers. Terraform works in a plugin architecture. Terraform works with a plugin architecture. The Terraform plugins are called providers. That providers let Terraform to interact with cloud platforms and any other services via their APIs. As I already told, HashiCorp and the Terraform community, have written more than 1,000 providers. Already, they have written over 1,000 providers to manage resources on AWS or Azure or GCP using Terraform. With a Kubernetes provider, you can manage Kubernetes resources also in your Kubernetes cluster, or you can manage GitHub resources also using GitHub provider using Terraform. Like you can manage resources on any platform or any service provider using providers concept. As I already told, you can find the providers for many of the platforms and services in Terraform registry. There is something called Terraform registry. This is the link I have given here. There are various providers: AWS provider, Azure provider, Kubernetes provider, like this. So using appropriate provider as per your requirement, you can manage the resources on this provider. You can use this AWS provider. Using this AWS provider, you can manage the life cycle of AWS resources like EC2, EKS, S3, RDS, and many more. Suppose if you use Azure provider, using Azure provider, you can manage Azure resources like Azure virtual machines, Azure VNets, Azure Kubernetes clusters, or Azure databases, or Azure load balancers, like that. So using Terraform, you can manage any infrastructure. Terraform is basically based on the plugin architecture. So using Terraform plugins called providers, you can interact with any cloud platforms and any other services. Already Terraform and the community have written over 1,000 providers to manage the resources. And Terraform is open source. As I already told, Terraform is open source. Terraform is available for use as an open source software, which means free of cost. You can use Terraform for free of cost. But Terraform has an enterprise version also, guys. Terraform has an enterprise version also, that is Terraform Cloud. That is Terraform Cloud. Terraform is open source and free. Terraform Cloud is enterprise. Clear? Terraform also available in two variants, Terraform and Terraform Cloud. Terraform is free and open source. Terraform Cloud is an enterprise version. Clear? Again here. Is everyone clear? Terraform also has a two versions. One is Terraform, another one is Terraform Cloud. Terraform is free and open source. Terraform Cloud is enterprise. Now, the important feature in the Terraform, state management. The important feature in the Terraform is state management. So will maintain, Terraform will maintain, Terraform will maintain information about the resources it has created in a state file. Terraform will maintain the information about the resources, what resources has been created by Terraform is maintained in a state file. So this state file enables Terraform to know which resources are under its control and when to update, when to destroy those resources is based on the state, Terraform state. Terraform uses this state, Terraform uses this state to map the real world resources to our configurations. That your configuration is like your desired state, what you need. Your Terraform script, your Terraform configuration is like your desired state, what you need, like EC2 instance. If it is already created by Terraform, it is part of the state file. Can we consider that state file as a current state? The state file is like a current state. What is the current state of your actual resource? Yes. So Terraform will maintain the state of the resources which is managed by Terraform under state file. So Terraform will compare the desired state, that is your Terraform scripts, with the current state, that is your state file. So if there are any changes in the desired, that is your configurations, it is going to make a changes to the real resources in the cloud. So Terraform state is stored locally by default. Give me 1 minute, guys. Give me 1 minute. So Terraform is going to compare the desired state with current state. Desired state is your configurations, your Terraform code scripts with current state. The current state is being generated and managed by Terraform only. The Terraform state is stored locally. The Terraform state is stored locally by default on the machine where you are running your Terraform scripts. But it can be stored. Terraform can maintain the state file remotely also. This is preferred. This is preferred in a team environment when multiple people are working. When multiple people are working on the infrastructure. So instead of maintaining that state file locally in a particular machine, you can maintain the state file remotely in the remote backend. So Terraform state file contains actually the content of the state file is in a JSON format. The content of the state file is in a JSON format, mapping of the resources defined in the configuration and those exist in your infrastructure. So when Terraform is run, it can use this mapping to compare. when we are running the Terraform scripts, when we are applying the Terraform script, the Terraform will use this mapping, the Terraform state mapping, to compare the infrastructure to the desired state, and it will make any adjustment as necessary as per the current state. So Terraform uses this state file to create a plans and modify our infrastructure. As I already told in the last class, avoid directly mapping the Terraform state file. You should not modify the Terraform state file. Avoid directly manipulating the state file. The Terraform state file is meant only for internal use within Terraform. This implies that we should never manually edit the Terraform state files. You should never manually edit the Terraform state file. The Terraform state file is generated and used by Terraform. So if for some reason we need to manipulate the state file, there is some state related comments. That we will discuss in detail separately. Terraform state related commands like Terraform import command, Terraform state commands. If for some reason we need to manipulate the state file, use a Terraform import or Terraform state commands. This we will discuss later. But manually, we should never edit the Terraform state file. Clear? What do you mean by state file? Just to make things simple, you are going to write a Terraform script. Let's say this is your Terraform script. You have written a Terraform script such a way that you are saying resource. We will discuss in detail all these things, okay? You are saying, let me write maybe in a notepad. We will discuss all these things in detail. Let's wait to understand the state. Some AMI you are using, just to give an example. So this is your Terraform configuration, Terraform script or configuration you call it. This is considered as your desired state, what you are looking. This is considered as your desired state, your infrastructure as a code. This is your desired state. Let's consider this is your configuration, Terraform configurations, code, infrastructure as a code. And you are trying to run this Terraform against AWS. This is your AWS provider. Now, when you are using Terraform for the first time, when you are running, so you don't have any state file, you have not created, it is like empty. So when we apply this as per this infrastructure code, there is no state as of now. Current state is empty because you don't have any resources already created using Terraform. Using this Terraform configuration, the resource is not created, current state is nothing. So as per the desired state and there is no current state, it is going to create a EC2 instance using this information. And once this Terraform provision this infrastructure, provision this resource, it will maintain this information in a state file, Terraform state file. So it is going to generate and maintain the file. The file name will be Terraform dot state. So it is going to have all the information, the current state of your resource here. Now, whenever I am changing something, suppose I am saying instead of t2.micro, I want to create a t2.medium. So this is my desired state, current state t2.micro, current state t2.micro. So when I am applying this change, what Terraform does? What Terraform does? Terraform will compare the current state with the desired state. If there are any changes in the desired state, your code as per the current state, it is not there. There are some modifications to your infrastructure code, which means there is some change in the desired state compared to the current state. So if I apply this change, what Terraform does? Terraform knows that this has to be updated. So Terraform will again modify the resource. It will create a t2.medium instance instead of t2.micro. The instance, the resource gets updated. So Terraform will maintain. It is going to keep a track of every resource it has been created and managed. So state is very, very important. So desired state is your infrastructure code. Current state is that state file. So is it recommended to manipulate or edit the state file manually at any point of time, at any cost? No, not at all. So you should avoid, you should avoid manipulating the state file manually. So it will maintain locally. The Terraform will maintain the state file locally wherever you are running your Terraform script. Wherever you are running in the Terraform script, it will maintain. But when multiple people are working, multiple team members are collaborating and working on this code. Let's say, Balaji is also working here, and let's say Akbar is also working on the same Terraform code. So Balaji is working, and Balaji system in Balaji laptop or desktop, whatever he is using, let's say I have this code I ran. Again, Akbar also getting the same code, and again he is running. Akbar is also running. By default, it is using the state file, local state file. Since there is no state file here, again, is it going to consider there is no resource with these configurations already in that cloud? So is it going to duplicate that resource here? I mean to say, if Akbar is going to run again, is it going to duplicate the resources here? If we are using local state file by default, yes. So if you are using local state file, Akbar is running the Terraform code, he's in laptop, same resources he is trying to create, it is going to duplicate in the same cloud platform. So this is not recommended when multiple team members are working. So when working with the Terraform in a team of people, using a local file complicates Terraform usage, because each user must ensure that they always have the most recent state file before running Terraform, that no one else runs the Terraform at the same time. So when we are working as a team with the Terraform, we have to go with remote state. We have to go with remote state instead of maintaining the state file locally. So you have to go with the remote state. So if we are using remote state, Terraform will write the state file into the remote storage, remote data store, which can then shared by all team members. Terraform can store the state in a variety of storage platforms. If you guys are using AWS, you can use S3. In S3 bucket, you can maintain the remote. I mean to say, Terraform can write the state file in the remote backend like S3, or Azure Blob Storage, GCS buckets, Terraform Cloud, or console like that. So practically, we will discuss this remote state file. But is everyone understand how important this state management, how Terraform is managing the infrastructure resources, how it is comparing the current state of your resources and the desired state of your resources? Is everyone clear? What is state file? how important the state file in Terraform, for what purpose Terraform is generating and using the state file. This is one important feature. So remote state backend is implemented again using some keywords. We will discuss this later when we go for a labs, all these things. But before I proceed, let's understand how Terraform works. Terraform architecture. As I already told in the last class, at high level, Terraform can be considered or consisting of two components. At high level, Terraform can be thought of consisting two main parts. We already discussed Terraform core and Terraform plugins, that plugins called as providers. Terraform core and Terraform plugins called providers. The Terraform core is responsible. The Terraform core is responsible for lifecycle management of your resources. Terraform core is responsible for managing the life cycle of your infrastructure resources. Life cycle in the sense creating, updating, deleting your resources. Basically, the Terraform core is nothing but that open source binary, that software. Terraform core is nothing but the open source binary that you download and use from the command line. Terraform core is nothing but that open source software. Terraform core is nothing but that open source software that we will download and use from the command line. Terraform core will take two input sources. Which are your Terraform configurations, that is your code, your Terraform script, that is your desired state. You are going to define your desired state of the resources in the form of Terraform configuration files. So Terraform core will take two input sources, which are your configuration files, Terraform configuration files, that is desired state, and the second the current state, the state file, the current state, basically the state file. So the state file is managed by Terraform only, which is generated and managed by Terraform. The state file which is generated and managed by Terraform. So using these two inputs, right? Using your Terraform code, your Terraform script, basically your configuration, that is desired state, and the current state, the state file which is generated and managed by Terraform only. Okay. So using these two, with this information, the Terraform creates a plan of what resources needs to be created, updated, or removed. So is everyone clear what is Terraform core here? What is the role of Terraform core? What a Terraform core will take as an input to manage your resources, your infrastructure resources, your Terraform resources. Is everyone clear what is Terraform core? Before I go for a Terraform plugins or providers. So current state, that is state file, and your configuration file, that is your desired state. These two will be used as a input for Terraform core. Terraform core is a software. Terraform core is a CLI. Terraform core is a binary. That software we downloaded, that is Terraform core. Terraform core will take two input sources. One is your Terraform script, that configurations, and the state file. Terraform core is a binary. Terraform core is a software. It will take two inputs. That is your Terraform files and state file. Clear? Vijayalakshmi is saying current state comma configuration is core. No. Terraform core is a software, a binary, that open source binary, open source software that we download to use Terraform. It will take two input sources. One is your configuration files and current state. Clear, everyone? Terraform state. If you understand the architecture and flow of Terraform, it will be easy for you to write a Terraform code. That's why I'm spending so much time here. You need to understand that the Terraform. What is Terraform? What is the Terraform architecture? What is the Terraform flow? If you understand all these, writing a Terraform code, creating a resources and managing the resources using Terraform is easy. That's why I'm discussing so many times this, the architecture. Now there is second one. There is a second one, Terraform plugins. Terraform plugins called providers. Terraform plugins called providers. As I already told, what is providers? We already discussed all these things. Terraform plugins called providers will interact a Terraform core to interact with the cloud platforms and other services to create and manage the resources. So this is the architecture. So this Terraform core is nothing but a software, a binary. So what is the input? I mean to say, what is the input for the Terraform core? To manage, to provision, to manage or update or delete resources in any platforms, any providers. Terraform core will take your Terraform configuration files, that .tf files, .terraform files, where you have defined your resources, and it is going to use state file. So it is going to compare, this is your desired state, this is the current state. So by comparing the desired state with current state, it will generate a plan. It will generate a plan, what resources needs to be created, what resources needs to be updated, what resources needs to be destroyed. It will create a plan, and using those providers, it will manage the resources in that respective platform. It can be creating or updating, deleting. So is everyone clear? What is Terraform architecture? What do you mean by Terraform core? What is expected by Terraform core? And Terraform core will, how it will manage the resources, provisioning the resources basically using providers. Is everyone clear about this architecture diagram? Is everyone clear? This is what we discussed in the last class. This is what we discussed in the last class. In today's session, let's try to understand something new. Let's try to understand something new. Terraform language. Terraform language. You need to write a configurations. You need to write a configurations for in Terraform to manage your resources. You need to write a Terraform script, a Terraform configurations. So using what language? Using what language you are going to write those configurations, Terraform configurations? Terraform is developed in Go language. Terraform is developed in Go language, but Terraform is declarative way, which means, do you need to write any programmatic code, programmatic scripting? Do you need to write any kind of a Java code or Python code or Go code, Go language like that to write your Terraform configurations? No. You no need to write any complicated code, complicated scripting or complicated programmatic scripts. Terraform is a declarative way. You are going to write a Terraform scripts, your Terraform scripts in HCL. In HCL, it is not HCL technologies. HCL stands for HashiCorp configuration language. HashiCorp configuration language. So HCL, HashiCorp configuration language, is a domain specific language. HashiCorp configuration language is a domain specific language. It's a domain specific language used to define your infrastructure as a code in the Terraform. You are going to use HCL, HashiCorp configuration language, a domain specific language used to define infrastructure as a code in Terraform. Infrastructure as a code in Terraform. So this HCL is used, this HCL, this HCL is used to describe, HCL is used to describe the desired state of your infrastructure resources. Using HCL, you are going to write your Terraform configurations. Using HCL, you are going to describe the desired state of your infrastructure resources. So configuration files, the configurations files you write using HCL. The configuration files you write using HCL in a Terraform language. Tell Terraform, it will tell Terraform what plugins needs to be installed, what infrastructure resources needs to be created, and what data needs to be fetched, like that. The configuration files you write using HCL in Terraform will tell Terraform that what plugin needs to be installed, what infrastructure needs to be created, what data needs to be fetched, like that. So HCL is a human readable language. It's a human readable language, very easy to understand, easy to learn and write. HCL is a human readable language that intends to be easy to learn and write, and HCL will allow you to describe, HCL will allow you to describe the desired state of your infrastructure without specifying the exact steps. HCL will allow you to describe the desired state of your infrastructure resources without specifying the exact steps to achieve that state. You no need to define exact steps. You just define what you need. Just to give an example, here, did I define how to achieve this desired state? My desired state is I want to have a AWS EC2 instance of type T2.medium with AMI, whatever AMI I have provided. This is desired state. But did I created a detailed steps to achieve the desired state here? Did I mention any detailed steps like what actions, what steps has to be taken care to achieve this desired state? No. I just define what I need. I just defined the desired state. Is Terraform knows how to achieve the desired state? Whatever you defined, does Terraform knows how to achieve the desired state? Yes. Terraform knows how to achieve the desired state, but you are just defining. You are not saying how to do that. You are not describing how to do that. So HCL will allow you to describe the desired state of your infrastructure without specifying the exact steps, to achieve the state. Terraform knows how to achieve that desired state. So HCL is a full form of HCL is a HashiCorp configuration language. It's a domain specific language used to define infrastructure as a code in Terraform. HCL is used to describe the desired state of your infrastructure resources. Configuration files you write using HCL in Terraform will tell Terraform what plugins to install, what infrastructures to create, what data to fetch, like that. So is everyone clear what is HCL? First of all, the Terraform language, what language is used to write a Terraform configurations? Is everyone clear? Before I proceed, now let's understand the syntax. Let's understand the syntax of HCL. Let's understand the syntax of HCL. HCL syntax comprises blocks. If any Terraform script, any Terraform configuration you take that contains some blocks, this also I can consider as one block. This also I can consider as one block. So HCL syntax comprises, which means contains blocks. HCL syntax comprises in the sense contains blocks that define a variety of configurations. HCL syntax comprises blocks that define a variety of configuration available to Terraform. You can define various configurations in Terraform using that HCL blocks. Using that HCL blocks. Blocks are basically blocks are basically blocks are like a containers. Don't get confused with the Docker containers. Don't consider this Terraform block is a container. Don't consider like that. That Docker container is different. Here blocks are like a containers for some content. Blocks are containers for some content. You are going to define some content in the form of block. You are going to define some content, some information in the form of block. So blocks are containers for other content. So don't get confused with this container terminology. This is not a Docker container. This is not a container, right? The container is like blocks are like a containers for some content. So which means using blocks, I can define some content, some information. So blocks are containers for other content and usually represent the configuration of some kind of object like resource. Blocks are containers for some content. Usually these blocks will represent some configuration of some objects like a resource. So block have a type. Block have a type and they can have a 0 or more labels. Blocks have a type. This is the general representation of block. Block have a type and they can have a 0 or more labels, like this is one label space another label, like that. Blocks have a type, blocks have a 0 or more labels and followed by flower brackets, within that flower bracket. You are going to define the body for that resource, body for that block. So blocks have a block type, can have a 0 or more labels followed by a flower brackets. Within that bracket you are going to define the body. That block body contains any number of arguments, and nested blocks. Within the block you can define again some sub blocks. most of the terraform features most of the terraform features are controlled by top level blocks in the configuration file. So this is the general representation of a block type followed by one or more labels for that block, and within a flower bracket you are going to pass the arguments, you are going to define the arguments for that block. So blocks are comprised or consist of key value pairs. Terraform will accept value, any type of value like a string value, number value, boolean value, maps or list. In this block arguments, it can accept strings, it can accept numbers, it can accept maps or list, like that. And again, if you need to comment something in the Terraform configuration, if you need to comment something in a Terraform configuration, single line comments you can use hash character. Single line comment you can use hash character in the Terraform configurations. While multi-line comments use an opening like this and closing like this. This is multi-line string, multi-line comments. So in Terraform scripts, you want to comment some line. You can use single line commenting, hash character, multi-line commenting, starting this, ending with this. So let's take a resource block. Let's take a resource block to understand the blocks concept here. Let's take the resource block from the previous article here, and let's understand how it works. So here block type, I am saying resource block, and here like this is like a block label, another block label. This is type of the block, that is resource block in Terraform, and this is one label for that block, and this is another label. Top level blocks in the sense which you can define in any location in the Terraform script, which you can define any location in the Terraform script. So this is top level block. This is top level block. If you see within this block, I am having something else like this. This I can consider as what? Top level block or nested block. You see within this block, starting here, ending here, and within this block I have one more block. This what I can consider? Can I consider this as a top level block or nested block? Nested block. So Terraform features, most of the Terraform features are controlled by top level blocks only. So these top level blocks, we can have a nested blocks. Top level blocks like resource block is top level block that can have a nested blocks, but most of the Terraform features are controlled by top level blocks. Resource is one top level block. I will come to that. What are the blocks? Different types of blocks we have in Terraform. I'll come to that point. Just to explain the general representation of block, I am taking this resource block. First of all, you don't know what is this. You don't know what is this as of now. You don't know what is this, but I am trying to explain the HCL block syntax. So if you see, this is one block, block type. What type of block this one? What type of block this one? Type of the block as per this. What type of block it is? Block type. What type of block here? Resource block. And each block can have 0 or more labels. Can I consider this is one label for that block? This is another label for that block. You can consider as alias or name for that block, like that. Yes, and followed by double flower brackets. Within this bracket you can define the body. That body is nothing but some arguments. So this is the example of the block, some block. Now here we have a block of type resource. Here we have a block of type resource. Since we are using AWS provider, right? You can check the documentation here. Since we are using AWS provider, you can check the documentation here. So I have provided a documentation, AWS documentation. So here, if you see, this is like one block. This is like one block. This is like one block. Resource block, resource type, resource label, right? Type of the block, resource block. And since we are using AWS provider, if you want to see more details about that, you can see that link. But let me explain here. So this resource block, this first one, AWS underscore instance. AWS underscore instance is like the label. It is like the first label that points to the type of AWS resource. What type of AWS resource? This is pointing what type of AWS resource it is, like AWS instance, that is like a EC2. And this one, app server is the second label that represents the name of the resource. that represents the name of the resource. The name of the resource in Terraform. Resource name in Terraform. Name of the resource in the Terraform. So these names, these Terraform names, Terraform supports accessing these elements. Terraform supports accessing these elements in any other configuration also in a dotted notation. In a dotted notation. So some resources may have a required arguments. These are like arguments. These are like arguments for this type of resource. But what arguments can be used? That you can only find out in the official documentation only. Each and every resource provider, each and every resource type has its own official documentation. What arguments can be used for this resource? These key value pairs you can find in the official docs only. In our case, AWS instance is one resource. AWS instance is one resource that you can provision using Terraform AWS provider. AWS instance has two required arguments, that is AMI and instance type, like this, mandatory arguments. So Terraform is in the form of HCL. Your HCL syntax comprise or contains blocks that define variety of configurations available to Terraform. Blocks are containers for some content, usually represents some configurations like resource. Blocks have a block type. They can have 0 or more labels followed by double flower brackets that contain some body. Body is nothing but some kind of arguments. So this is just an example of resource block. Block type is resource. These are like a labels for that resource, and these are the body of the resource. And Terraform has various types of blocks. Terraform has a various types of blocks. As part of Terraform, right? As part of Terraform learning, we will have various type of blocks: Terraform block, provider block, resource block, variable block, locals block, output block, module block, data block, like that. So in your Terraform script, everything is a block. Everything is a block where you are going to define some content. Some content usually represents some kind of a configuration. Blocks have a block type, can have a 0 or more labels, and followed by brackets that contains the block body. And it can have any number of arguments and nested blocks, right? So this is just an example of resource block. So is everyone clear what is block? In HCL, everything you are going to define in the form of block. Block has a type, block has a body, block has a labels. Clear? What do you mean by block in Terraform? Everything in Terraform script is a block. That block is like a container for some content, some information. Is everyone clear what is block in HCL? These are very, very important fundamentals you need to know before you write the Terraform script. You should not by heart anything here. You need to understand what is Terraform block, what is provider block, what is Terraform block, what is resource block, what is variables block. You need to understand. But before I explain what, is everyone clear what is block first of all? Before I explain all these blocks, Terraform block, provider block, resource block, first of all, is everyone clear what is block when it comes to Terraform? Now let's understand the various types of blocks, the various types of blocks, the various types of blocks we will have in a Terraform. So as part of Terraform, we are going to use various blocks: Terraform block, provider block, resource block, variable block, locals block, output block, module block, data block. So We'll try to understand. We will go over basic structure and purpose of each block. First, we will understand the basic structure and what is the purpose of each block here. Once we are familiar with these blocks, Terraform block, provider block, resource block, variable block, locals block, output block, module block, data block. Once we are familiar with these blocks, then we can start building the infrastructure. That start resembling something useful for you. You can write your code once you are familiar with these blocks. So let's understand what is Terraform block. Let's understand what is this Terraform block. Terraform block, Terraform block is used. Terraform block is used for setting the version of the Terraform which we want to use. The version of the Terraform which we want to use, and it may also contain required providers. It may also contain required providers block inside. Terraform block is used for setting what version of the Terraform we want. What version of the Terraform we want to run this Terraform configurations. And also the Terraform block, within the Terraform block, you can define required providers. Terraform block can contain required providers block inside, which specify the version of the providers we need, as well as where the Terraform should download these providers from where it has to download the provider, and what provider is required, what version of the provider is required, you can define. So example, here is the example of Terraform block. If we guys are using Terraform 0.13 plus above, 0.13 plus above, 0.13 and later versions, or later versions, this is how you are going to define the Terraform block. So by looking at this, you can understand this is Terraform block. Required version greater than or equals to 1.3.0. What does it mean? Are we informing Terraform that I need Terraform version? The Terraform version should be greater than 1.3.0. If I am running this script, but my Terraform version is 1.2.9, does Terraform will throw error saying that you are expecting 1.3.0 version to run this configuration, but the current version of the Terraform software is 1.29, like that? Yes. So you can say the required Terraform version to run these configurations in the Terraform block you can define. So is everyone clear? Terraform block is used for setting the Terraform configurations. Terraform block is used for setting the configurations of Terraform, right? Terraform block is used for setting the configurations of Terraform, like a version, what version of the Terraform is required, what providers has to be used, what providers is required, and what is the version of the provider, and where the source of the provider is there. This is like a settings. Your Terraform settings you are defining in the form of Terraform block. Is everyone clear? The first and foremost important block. What is this Terraform block? What do you mean by this one? I am saying Terraform, I need this version of the Terraform greater than or equals to this one, and I need a AWS provider. So why I am saying AWS provider? In case if I have to create and manage AWS resources, can I inform Terraform that I need AWS provider and download the AWS provider to create resources like that for my Terraform to inform? Yes. So is everyone clear? What is this Terraform block? What is the version, right? Provider version. What AWS is one provider. What version of the provider? Provider is nothing but set of APIs in the background. I hope you understand that point. Providers or plugins are nothing but set of APIs. So what version of the provider, AWS provider, you want to use to manage the resources in AWS via Terraform? This version is provider version. This version is Terraform version. Clear? Because your resources, your resources and arguments, based on the providers and its versions. Suppose you are using AWS resource, you are defining a AWS resource like this, but you are using some argument, but that arguments are not supported in the older version of the provider. Again, if you are using some resource and arguments, if this resource specification, is not there or not correct as per this version, again do you have a problem when you are applying that resource via this provider? This is like a specifications only, guys. Just to make things simple, if you guys know Kubernetes, can I consider Kubernetes is also kind of orchestration? Yes, but Kubernetes is also there, state, Kubernetes state. Using Kubernetes, are we able to manage Kubernetes resources that can be creating, updating, deleting, like deployment, like service, like config maps or secret, like that? These are Kubernetes resources, right? So you are writing in the form of YML. You are writing in the form of YML. You are saying something like this. But let's say you are doing something wrong. You are passing some wrong arguments. Let's say here you are saying some wrong arguments. Is Kubernetes will able to understand whatever arguments you are passing, some invalid arguments? Does Kubernetes will understand what you are passing? This is not as per the specification. Let's say you are passing something like this. Does Kubernetes will be able to create this resource in the Kubernetes if you pass something junk here like that? No. So same concept here. You are able to create and manage the resources in any provider. You are able to create and manage the resources using any provider. You are using some provider version, but you are using some resource. You are trying to create that resource using that provider. But here, if I say something like this, different or some unsupported argument, it will not work. So make sure you are informing Terraform. What version of the Terraform you need, what version of the provider you need, also you can define in the Terraform block. So this Terraform block is like a settings for your Terraform, what version of the Terraform we want, and we can define required providers which specify the version of the source, from where you need to download this provider, what version of the provider you need to download by the Terraform, what version of the plugin or what version of the provider or plugin it has to download. Is everyone clear? What is this Terraform block? Very, very important. Now coming to your point, right? Suppose I want to manage resources in AWS. I can use something like this. Suppose I want to manage resources in Azure. Can I use that Azure provider? Terraform registry has a various providers. Let's say you have a providers. I can browse the providers. Let's say If I have to work with Azure, can I define my Terraform configuration like this? I hope you can understand now. So here in this example, I have defined something like this. Now suppose you want to manage your infrastructure using in Azure. Can I say Terraform block? Within Terraform block, can I say Azure? I need Azure provider to create and manage resources in Azure like that. And what version of the Azure provider or plugin you need like this? This is like a settings. This is like a settings. This is like a settings. Guys, everything is documented here. Everything is documented here. You no need to by heart anything, but you need to understand the Terraform. What is Terraform? What is the architecture of Terraform? What is state? What is provider? So if you know the provider, everything is a provider here. Everything is a plugin. Suppose you go and see here, GCP plugin is there. GCP provider is there. They are giving the documentation. You no need to by heart, guys. This is a coding. If you hard code or if you by heart the scripts or codes, if you hard code or by heart the scripts or codes, will you able to work on based on your requirements? No. You have to understand the concept. If you see there is, this is also one provider. So can I use something like this? Provider information. If I have to use Google provider, yes, provider Google. Under which region? What is your Google project ID? Google has different concepts. So Google you are going to manage the Google resources under one project. You are saying under this project, under this region, I want to manage Google resources. Like this, you need to understand. Guys, this is greater than and less than symbol. I think you guys understand what is this. This is basic arithmetics, logical. Now, this can be, if I am giving like this, is this condition also satisfied, whether it's a 7.0 or whether it's a 7.0.1 also fine for me, whether it's a 2.7.2 also fine for me, greater than or equals to this version. I hope you can understand what do you mean by greater than, what do you mean by equals. This is, suppose you are using this version of the provider also fine, this version of the provider also fine, this version of the provider also fine. But let's say if you say exactly like this, if you say exactly like this, so it is always going to download this one. It is always going to download this one. It is always going to download this version. Even though there are later versions, even though there are later versions, when you are installing, when you are initializing the Terraform, is it going to download the latest version? If you say version something like this, is it going to download the latest version of that provider, even though you have a latest versions of the providers are released? No. So if you say something like this, it can download this one or any later versions also. Greater than or equals to, guys, nothing complicated here. If you need to download specific version, if you need to download specific version, mention something like this 2.7, or it can be greater than or equals to, suppose you say something like this. After this one, there is a new provider. I mean to say AWS has released a new version of the provider. Will it download the latest version? Suppose as of now in Terraform, this is the latest AWS provider. If I say something like this, is it going to download this version of the provider if this is the latest? Yes. So this is like which version of the plugin or that provider you need to download. If you say equals to, or if you say something like this, always this one. If you say greater than or equals to, this can be this one or any other later version also it can download. Clear? This is basic arithmetic concepts. Clear, Archana? Especially you have some doubt here. So Terraform block is very important block where you are defining what providers you want to use. Just to make things simple, my requirement, I want to manage AWS resources using Terraform. AWS resources such as EC2, EBS, EFS, ES3, RDS, EKS, VPC, whatnot, etc. Then in my Terraform configuration, do I need to define something like this? What provider I need? So if I have to manage infrastructure on AWS, I want to manage that, manage in the sense creating, updating, or deleting using Terraform. Can I define in my configuration something like this as per your requirement? Yes. Suppose you want to manage resources, you want to manage resources on Azure, you want to manage resources on Azure, then can you define something like this? What provider you want to use? Azure resources such as Azure VM, Azure Virtual Machine, Azure Disk, Azure File Store, Azure File, or Blob Storage, Azure Blob Storage, or AKS, or ACR, or VNet, Azure VNet, or Azure VNet. You need to define in the Terraform that I want to use this provider to manage my resources. Is everyone clear how important this Terraform block? Is everyone clear what is this Terraform block? First of all, Terraform block is used for setting the configurations for Terraform, like what version of the Terraform we want and what providers we need, which version of the provider we need, and from where it has to download, like that you need to define. So here is an example for Terraform block. Here is the example for Terraform block. If you are using Terraform 0.1.3 plus later versions, like this. But if you are using older versions, if you are using older versions, there is a different way. If you are using a older versions, there is a different way. Only this one, like this you are going to use. So is everyone clear? Terraform block. What is block and what is Terraform block here? Block is like a container for some information. There are various types of blocks in Terraform. Terraform block, provider block, resource block, variable block, locals block, output block, module block, data block, like that. So first understand what is this Terraform block. Whatever has been discussed today, try to understand. From tomorrow, I will continue from here. What is provider block? What is resource block? At high level, we will discuss all these blocks. Later, we will install Terraform. Later, we will start writing the configurations. But without understanding these blocks, you can't create a configurations, Terraform configurations. So I'll continue from here tomorrow, guys. So try to go through this session, and I'll share this document also. Whatever I am walking you through, I will share this document also. Understand till here, Terraform block. From here, I'll continue tomorrow. Tomorrow only, we will install the Terraform. We'll understand all these blocks, then we will install Terraform. Then we will write the Terraform configurations using these blocks. Clear? Any questions, any queries, let me know. Otherwise, I'll start the session here. Sir, if you lost the state file, how we match the desired state? So Arvind, wait for all these concepts, because first of all, most of the people don't know the state file itself. So we will discuss. First, I am explaining the basics. First, focus on the basics. Advanced concepts automatically you will understand. First, focus on what is Terraform, what are the features of Terraform, what do you mean by Terraform state, what is Terraform architecture, what is blocks, what is Terraform block, provider block, resource block. This is very, very important, because you take any Terraform script. Let me show some sample Terraform script which I already have. I have a sample Terraform script. I have a sample Terraform script for this EKS. By now, once you are familiar with all these things, once you are familiar with all these things, blocks, Terraform blocks, by looking at this, will you guys able to understand what you are doing? By looking at this, will you able to understand what is this, what is this, what is this? Even though it's a lengthy file, yes. But I want you to focus on what is resource block, what is provider block, right? What is variables block, what is variables block, how to use variables, how to use loops, how to use conditions. I want you to understand the concept of HCL first. Once you are familiar with HCL, then we will install, Terraform, then we will write the Terraform code. In detail, we will understand how to create EC2, how to create EBS, how to create VPC, subnets, route tables, all those things using Terraform concepts. First, focus on the basics, guys. That's why I'm explaining again and again the basics. Because this is code, this is configuration. If you by heart something, will you able to write configurations or code or script? What people are doing, right? You are by hearting something like this. This by hearting will not work out. You need to understand what is this block, what we can do use this block. What is resource block, what we can do using resource block. What is variable block, what we can do using variable block. What is data block and how to use data blocks. You need to understand those blocks. Then you can understand the Terraform easily. That's it for today, guys. I'll continue tomorrow. From here, I'll continue tomorrow. What is provider block? Again, the way you have a Terraform block, there is something called provider block. These are top level blocks. Whatever I am discussing here, these are top level blocks in the Terraform configurations. Thank you. That's it for today. I'll continue tomorrow, guys.